perception, perception, pretty much a neural network. So he just showed you how to get uh, the back propagation using torch, PyTorch, which is my focus. And okay, so we start with a neuron class, and we set the weights and the biases to random between -1 and 1. And then, so what we're doing here, this is like this is the forward pass of just calculating what the output of the neuron is going to be by multiplying all the weights by the value of x, like what the value of the neuron started as, and then adding the bias, and then passing it through tanh, which is the activation function, getting it between 0 and 1. Okay, and then now we're like making a layer for each class, a layer for the neurons, which is just, connecting each neuron in a column or row, whichever one. And then we got the multi-layer perceptron, which is giving. It's pretty just like setting up the. It's just setting up the dimensions, which is right here. So here we have our three inputs, our three neurons starting at 2, 3, and -1, and then we're gonna have three rows, three columns or whatever of the neural network starting at 4, with 4, 4, and 1 output, and over the n of x of what, and then combining all those outputs into one, we get this number. So right here now we set the desired targets of what we want to get. We want to get these our four neurons into our four neurons from here into these. We want 1, -1, -1, and 1. And then so what's the last column? The last column is the loss function. The loss function is what we want divided so that would be -1 to what we have, which would be 0.5, and then you square that, and that's your loss function, and then you average that out for all four, and then we get the gradients, and then to update the gradients we do -1 times the gradient, because we want the loss to be as small as possible. So that's why we're doing the -1. So if you, or the gradient's 2, so we multiply that. So you add a little bit of the gradient, right? A little bit of so you just want a small value that's in the same same sign as the gradient, so negative or positive. So you want we're adding the negative of that gradient to get the loss as small as possible. So just passing it, and then so you just keep on running this, and then you could and then you get closer and closer to 1, 1 or -1, and see how it actually works. So that's a step through. And then my problem set, unfortunately, my computer shut down and I lost all my progress, but it's okay because I didn't do so much on this anyways. So I'll just walk. So this is just this first section is just derivatives, of finding the derivatives. This is through calculus. So this is I need to find the gradient of a in respect to f. So that would just be, so in this huge equation, so I just -a to the third, and whatever using the power rule, and then adding that with this using the power rule, and then just finding the gradient. Very simple. And then this is using kind of the intuitive, using no calculus, right? Just so that would be adding a plus h, which is 0.001 to the 3, minus a plus h to the power of 5, and then doing that for all of them, and then you also get the same answers, but it's not as, you get answers to a certain point, but it's not as precise. And then there's the alternate formula um where it's like a plus you you do a minus h. Here, it's easier to just show you here. Um, yeah, it's like, so it'd be a plus h minus a minus h over 2h, and that's more exact. You get it to like better decimals. Okay, and then like this is what I had a lot of trouble doing. Um, Essentially just refitting this for the softmax function. Um, but so like I understand what the softmax function is. It's adding all the e to the power of, or to like the denominator. It's an activation function. This is very like Python syntax heavy, so I kind of like I tried. I like couldn't really didn't understand why I was getting all these error messages, so I just skipped it. And then also like um using the torch library, but he kind of like skipped over the torch library like very fast, and I didn't want to learn all of that. So okay, that's my research. I say that I'm very comfortable with how neural networks work, which was my goal. And going forward, I want to like learn PyTorch and Jupyter, and be able to understand the syntax. And I think I'd be able to make like some cool stuff. And then like broadening this out to more complex things is a very granular, like small case. Okay, thank you for watching.